So one of your chapters in term 3 is about hydraulics. So as you know, hydraulics are used to be able to move objects. So let's say, for instance, you want to create a jack that's going to have to lift up a car. Then you have to apply pressure or a force on the one side that will move the car up on the other side. So how it works with a closed system. So that means that this system is sealed. There's no leaks, okay? And because of the area that the fluid is in, it builds up pressure that picks up it on the other side. And you'll always see the one side is smaller than on the other side, because the smaller your area is, the more pressure it's going to build up, because all of that liquid is forced in that side. Okay, so rules of hydraulics, because you have a certain amount of fluid in the system, as you can see here, that means that you have volume. Okay, now the rule says volume on the one side, so the amount of volume on this side is equal to the amount of volume on the other side. Obviously, because if you have a certain amount of fluid, let's say there's a liter of fluid in the system, just for argument's sake, then if it pressure rises on this side and goes to the other side, it doesn't leak, so there's no fluid that's getting lost. So the amount of the volume on the one side has to be on the same as on the other side. Now the formula for volume is stroke length times area. Stroke length is how far my pistons move. So let's say this piston has to move a certain amount down to be able to pick this piston up to pick up the car on that side, if that makes sense. Okay, now if I tell you that the volume of A is the same as the volume at B, if I can't use this formula, then I can take this part and go replace it there, because what is the formula for volume? It's stroke length times area, and again equals stroke length times area. But on this side I'm going to use A, and on this side I'm going to use B's information. Okay, and the same rule actually applies to the pressure in the system. Okay, let me just erase this. So that means if they build up a certain amount of pressure at A, it has to be the same amount of pressure at B, because the fluid is the same. Okay, now the formula for pressure is F over A. Alright, so I can say F of A over area of A equals the force of B over the area of B. Okay, so that is how I can manipulate these formulas. If I can't use this one specifically, let's say they didn't give me the pressure in the system, then I'm going to go and use it at the bottom like that. Okay, so those are the formulas that I'm going to work with when I work with hydraulics. Now, let me just quickly see. Okay, so there's 3 types of questions that they can ask you. First of all, they can ask you to calculate the force at piston B to be able to lift the vehicle at piston A. So how much force am I going to need on this side to be able to pick up the motor on the other side, the 200 newtons? Okay, so we have to work out the force on that side. So that's the first question. Oh goodness, I must just keep the F there. Then the second question, they can ask you to calculate the pressure in the system. And then the third question they can ask you is to calculate the stroke length at piston B, again, to be able to lift the vehicle at piston A. Okay, so just pause the video and write down the questions, because I am going to erase the questions when I start doing the calculations. But I want you to look at the formulas now first before we go on. So to work out the force at piston B, so as I said, there's two formulas. There's volume equals stroke length times area, or there is pressure that's force over area. Okay, now to work out the force at piston B, the only formula that has force in it is that one. Okay, but they did not give you the pressure in the system, so I won't be able to use this formula specifically. So the one I'm going to have to use here is the P of A equals the P of B. So that means force of A over area of A equals the force of B over the area of B. Okay, then for the second question, if we look at the volume, the pressure in the system, we can just go use this formula over there. So P equals F over A. We're just going to use that formula because pressure is the one that we want. Okay, and you do have a force and the area of the one side. We're going to calculate the area on this side. And then the last one, the stroke length, to be able to calculate that. So stroke length is inside volumes formula. It's inside volumes formula over there. Now, that means they didn't give us anything about volume. Okay, so they did not say anything in the question or on the sketch about the volume. So what you're going to have to go do is again say the volume at A is equal to the volume at B. So what is volumes formula? Stroke length A times area A equals stroke length B times area B. Okay, so that is what we are going to use as in terms of the formulas. So you can pause the video and write that down if you want to. If in an exam, usually they give you the picture with all of the information on it. If they give it to you in words, go and draw a basic picture for yourself and add in all of the information. So you can pick which side must be A, which side must be B, and just stick with the information on the one side and the other side, just to make it easier for yourself. Okay, so I'm just going to erase the questions quickly so we can start doing them. Sorry. Okay, now before we start with the questions there, I just want you to go and convert everything, because as you know, if they give it to you just like this, it's stated in millimeters. But we don't work with millimeters, we work with meters. So to change the 50 millimeters to meters, I have to divide by 1,000. So that means my comma is going to move to the left-hand side. Now, the comma always starts at the back, so that means I'm going to, 1,000 is 3 times. So 1, 2, 3 times that my comma is moving. So 0,05 meters. Okay, so we don't use that then. And then for the green, again, 1, 2, 3 times, so 0,15. And then for the orange part, again, 1, 2, 3 times, so 0,02. Okay, so it's just necessary for us to use the meters and start with the meters, so you don't have to convert it while you're busy, then you make less mistakes. So for question 1, to calculate the force at piston B, we said we're going to say P of A equals P of B. So F of A over area of A equals the F of B over the area of B. Now, this is the diameter of the piston. It's not the area of the piston. So we have to go calculate that first. So for me to be able to calculate the area, remember a piston is a circle and it's solid. So that means it's pi d squared over 4, the formula. So we're going to say pi bracket 0,05 because we're working with a, remember, over there, divided by 4. Okay, so when you type it into your calculator, you're going to say bracket, shift, and then at the bottom pi, then make a bracket. Oh, I said bracket, sorry, I meant that was a fraction. So fraction, shift, pi, and then make a bracket. And then you're going to say 0,05, close the bracket, squared, go to the bottom and say 4 and equal. Okay, so that gives me 1,968. We always round off to 2 decimals, so the 8 makes the 6 a 7. So it's going to be 1,97, and then don't forget the part at the back. So 1,97 times 10 to the power of negative 3, and this is in square meters. Okay, so that is the area on this side. Always fill it in on your sketch, because then you have the information at hand as you go along. Then we need to work out the area of B. So that's going to be the 0,02. Same formula, but now we're replacing it with 0,02 over 4. Okay, again, fraction, shift, pi button, okay, 0,02 squared over 4. And then it's going to give us 3,14 times 10 to the power of negative 4 square meters. Okay, and I'm going to fill in my area there as well. Okay, and then we're going to go back to the formula now. So the information at A will be 200 newtons for the force over 1,97 times 10 to the power of negative 3. Okay, equals, we don't know what the force of B is, so we're just going to write a F, and then the area for B is 3,14 times 10 to the power of negative 4. Okay, now we know that we have to do basic math here now, manipulation. So this is divided, F divided by that. So what is the opposite of divide? We have to multiply. And what I do on this side, I have to go do on the other side as well. Okay, so then these two cancel out. So when I type it in my calculator, you're going to type it in like this. I will put in a bracket, then fraction 200 over 1,97, then this button, I press only that button and I just say minus 3. You do not have to put it in as an exponent. Go to the side, close the bracket, times 3,14, again this button, and just minus 4. Okay, you'll see the answer is going to be a fraction. Just press S to D and it will give you the answer. So that means the force needed at B is 31,88 newtons. And I'm going to put that onto my sketch as well. 31,88 newtons. Okay, so that's for question 1. Let me just erase this quickly. So for question 2, they asked you to calculate the pressure in the system. So pressure is F over A. Now I said that it's better to use the F and the A of what they have given you in the sketch. Okay, do not use this side because you calculated the F. So if you made a mistake on this side, then you can rather use the side that they gave you and you can still get marks if that makes sense. So we'll rather use A's information here to calculate the pressure. Remember, the pressure is the same on both sides. So 200 over the area, 1,97 times 10 to the power of negative 3. Okay, and then you just put that into your calculator. So 200 over 1,97 times 10 to the power of negative 3. Okay, so again, I just press this one and now minus 3, that's all, equals. Okay, the pressure is always going to be a lot, so don't get a fright when you see the answer. So it's 101,522,84, and it's in Pascal pressure. Okay, they may ask you to give the answer in kilopascal. So what you do is you divide by 1,000 then, because we're going backwards. Okay, so my comma is going to move 1, 2, 3 times, so it will be 101,52 kilopascal. If it was megapascal, it would have been divided by a million, so you have to move another 3 times. So that would have been 0,101 megapascal then. Okay, but they won't ask megapascal for a small number, just for a number that's bigger than that. Okay, so that is for the pressure in the system. Then on to our last type of question that they can ask us to calculate the stroke length or the volume. Okay, so I said we're going to have to use VA equals to VB. What is volume's formula? It's stroke length times area, and this side we're going to use stroke length of B times area of B. Okay, so stroke length of A we get over here 0,15, then times the area. The area is this one, 1,97 times 10 to the power of negative 3. We don't know what the stroke length on B side is. That's what we're trying to calculate. So you just say SLB. Okay, and then the area of B will be 3,14 times 10 to the power of negative 4 that I got from there. Okay, that's what we calculated. Now this time it's multiplied with one another. So the opposite will be divide with 3,14 times 10 to the power of negative 4 on both sides. Okay, so they cancel out. And then this I just put in my calculator. I'll type it in. So fraction 0,15 times 1,97, this button minus 3, okay, over 3,14 times this button again minus 4. Okay, and then the answer for the stroke length is then 0,941 meters. And then to put that in perspective, I can just say times 1,000 will give me the millimeters. So it will be 941 millimeters. So it has to move down 941 millimeters to be able to pick up the 150 millimeters on the other side. Okay, I hope this helps.